Okay, for this video, I'll be going through Chapter 2 Kinematics, Success Criteria A. Now, state what is meant by speed and velocity. Okay, so when an object moves, it changes its position in space. As the position changes, the distance from a reference point also changes. Now, distance is defined as how far an object traveled from a reference point. Okay, so you can take this as the definition. Okay, how far? So take note that distance is a scalar quantity. So scalar has only magnitude. Okay, there is no direction. Okay. Now, since distance is a scalar quantity, the total distance traveled by an object will be the sum of distance traveled throughout its journey. So even though, let's say, this is the starting point, it moves to the right and then it U-turns back. Okay, so maybe just at the point of U-turn, it has already traveled 2 meters, and then it moved back to the left and travel back to its starting position. So the distance traveled will be the sum of the distance traveled. The total distance will be the sum of distance traveled. So it will be 2 plus 2. So equals to 4 meters. Okay, however, displacement is defined as a distance traveled in a certain direction. So displacement is a vector quantity. It has both magnitude and direction. So if let's say displacement, I use red color. Now we use the same example. From this starting point, the object moved 2 meters to the right. Okay, and then move 2 meters to the left. However, because it returned to its starting position, okay, the displacement is 0. Okay, is 0. How do we get 0? Now, if we take the going to the right as positive 2, okay, and to distinguish that from going to the left, therefore, going to the left will be minus 2 meters. Okay, so this is how we distinguish. So positive and negative doesn't mean that something is good or bad. It just tells us the direction. Okay, so in certain questions, they will actually tell you, oh, going to the right is positive or going upwards is positive. Therefore, coming downwards will be negative and going to the left will be negative. If the question doesn't specify, you have to give your own specification. So in this case, maybe if I do the working, initially it was a positive 2 meters. That means it was displaced from its position by a positive 2 meters because it's going to the right. And we take it that for this example, going to the right is positive. However, after that, he actually moved to the left. Right? So positive 2 meters, subtract 2 meters, you'll get 0. And actually, if it went back to its original position, it has not been displaced, right? If it ended up in finally in the at the starting point, it has not been displaced. Therefore, the displacement is 0. Okay, and maybe if I were to continue the story, if it were to move to the left, instead of stopping at the starting point, it continued moving to the left for 1 meters. Okay. And because we say going to the right is positive, going to the left is negative, so the displacement will then now be negative 1 meter. I hope you all get this example. So again, positive, negative doesn't mean good or bad. It just tells us the direction. So with that, if you can understand it, we can move on to speed. Now, speed is defined as the distance traveled per unit time. So per unit means I have distance over time, or distance divided by time. So this is a formula that you need to memorize. This is a definition that you need to memorize as well. Okay, now the SI unit for distance is meters. You learn in chapter 1. SI unit for time is seconds. Therefore, SI unit for speed will be meter per second. Now, there's this thing called instantaneous speed. It is the speed of an object at a particular instance. So if, let's say I'm driving, okay, I will look at my odometer or the speed meter to tell me what is my instantaneous speed. Now, uniform speed is when the change in the distance traveled by an object per unit time is the same. That means they have the same change in distance for every second example. So example, if let's say an object moved 2 meters in 1 second, and if I want it to continue in this constant speed of 2 meters per second, right, for the next second, he also must travel at 2 meters, 2 meters, and so on and so forth, right? Therefore, then I can get the constant speed of 2 meters per second. So speed is actually a scalar, okay, because it is using distance. Now, for velocity, it is defined as the rate of change of displacement. Okay, so we can actually say that speed, if you want to have the same kind of definition, speed is defined as the rate of change of distance. Okay, so whenever you talk about rate of change, it must be over a certain time, over per unit time. Therefore, velocity is defined as the rate of change of displacement, and velocity is a vector. Now, please remember, vector means there is magnitude and direction. So it actually has the same formula. Okay, but if we were to use the previous example, okay, let's say a object, so he moved 2 meters to the right, okay, from starting point, and if we say to the right, it is positive, right? Okay, so we put as positive. So what's the distance traveled? It is 2 meters. And let's say, to throw in some element of time, it did that in 1 second. Once it has traveled 2 meters, it U-turn back to its original position, traveling a distance of 2 meters. However, because distance has no direction, okay, so the total distance traveled in this case, and I use blue color, later I'll be using red color for displacement, the total distance traveled will be 2 plus 2 equals to 4 meters, and it traveled over this time of 2 seconds. Therefore, the speed equals to 4 over 2 equals to 2 meters per second. Now, if I were to do my calculation for velocity, okay, so it traveled 2 meters going to the right, so we take it that it's positive, and time is just time, right? So there's no positive, negative. You can't go back in time. And having the object move back to the starting point, you will have traveled negative 2 meters, right? And he will do it in 1 second. So therefore, the displacement will then be equals to 2 minus 2, right? You sum them up. 2 plus minus 2, you get 0 meters. Okay. However, the time taken is still 2 seconds. Therefore, the velocity will then be 0 over 2, and it will give us a velocity of 0 meter per second. Okay, so this is for success criteria A.